Day 51, AP Physics, page 583, number 9. The key idea here is the work done by a gas as it expands is technically negative, or as it's being compressed, it's positive, that's energy being put into the gas. But if you look at the graph, the work done will be equal to the area under the graph during that each specific process. So in this example, if I go from A to B, the work done as the gas expands from A to B will be positive, will be negative. That's energy leaving the gas. It's going to be the area of it's basically a trapezoid, but it's going to be you can separate it into this triangle ABC and this rectangle at the bottom, BCV, well, that bottom rectangle. So I'm going to add those two areas. So from A to B, it's area of that triangle, and then the area of the rectangle. So in terms of the symbolisms given here, the triangle is going to be 1/2 the base, which is going to be 2v sub I minus v sub I is the length of that base. Basically, it's going to be v sub I if you bring it down here, times the height, and I took p sub I minus 1/2 p sub I. I just magically threw the negative in there, even though it doesn't come out negative, because the work is technically negative as the gas expands. Something's got to be negative, so I threw the negative in with the p sub I. That's a little bit of kind of hand waving there, but it's a negative work. The gas expands, by definition, it does negative work, and the net result is the area of that triangle is negative 1/4 v sub I p sub I. And then the rectangle is just the base going back over here to the right. It's the length of the base, which is just v sub I, because it's 2v sub I minus v sub I is 1v sub I. Once again, I'm just making it a magical negative here because actually, well, yeah, well, that total area, I'm getting at total area still because all that area together is a negative area as the gas expands. But the length of that rectangle at the bottom is v sub I, and the height of that rectangle is 1/2 p sub I. So that area and consistent area, which is a negative area for that total area under a line segment AB all the way down to the axis, is the sum of those two areas, which is negative 3/4 v sub I p sub I. This is all overkill in this case because really the shortcut is, well, if we take then the work done from B to C, process B to C alone. So that technically would be the work done from A to B. If they asked you for the work done from A to B, that would be the answer for the work done from A to B, solely from A to B, negative 3/4 v sub I p sub I. And from B back to C, that's the gas is being compressed, so you just find the area of that rectangle, which I already did. In this case, it would be positive 1/2 v sub I p sub I. So the network then, if you go around the entire cycle from A to B to C back to A, because from C to A there is no work done. I could have put that over here. I could have added that on, plus the work from C to A, which is 0. So I didn't put that on there because there's only two processes in which the work is done. But if I add those two areas up, I get negative 1/4 v sub I p sub I, which bottom line is the shortcut would have been down here in black. All you need to do for any process that's circular is find the area of the enclosed shape. In this case, it's a triangle. All you have to do is find the area of that triangle, which is the negative 1/4 v sub I p sub I. I think the solution set will say that the area is positive, but here there's more work done by the gas than on the gas, so technically you should put a negative in here for the net work done by the gas. I guess if you're asking, it's doing that much work. In terms of being consistent with the signage, it'd be negative work because the gas is doing the work.